Let's represent what happens to the energy of a group of electrons as they move through our simple circuit. At position 1, they have arrived just before the source, and they begin to move through the source itself. When that happens, that group of electrons will gain energy, and we call that a voltage rise. Position 2, the electrons have gained their energy and are now leaving the source. Next, they travel along the wire. As they move through the wire, we observed that the voltage measurement was 0. So there's no change in energy for this group of electrons. The energy value remains the same. Next, the electrons pass through the bulb. As they do, energy is transferred from that group of electrons to the bulb itself. When that happens, the electrons lose energy. After leaving the bulb, the electrons travel through the second wire and return to the source. Our voltage measurement, we saw no change in energy for that group of electrons. This picture represents an idealization because we made an important assumption about our wires. We assumed that our wires are ideal, so that the electrons do not lose any energy as they pass through it. In reality, things are slightly different. There is a tiny energy loss. A more realistic picture would look like this. This picture is a little more realistic. We see a tiny drop in energy as the electrons travel through the wire. So this is what happens in reality. However, the size of these energy losses is often very small. So when we make our ideal wire assumption, it is usually a very reliable one. So for our electricity work, we will stick to that assumption and that first graph that we drew, understanding that the electrons do not lose any energy as they travel through the wire.